Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Oilspill by Brigitte, and here are the rules. We need to place the digits 1 through 9 in every row, column, and irregular region, or irregular box, they say. It's not a box, but that's why I like saying designated 9-cell region, because you can always, even for irregular Sudoku, which this is, it's basically the same thing every time, right? In this grid, in every single cell in this grid, place a single digit such that we have in every row, column, and designated 9-cell region the digits 1 through 9 exactly once each. So it's exactly the same no matter what. So that is normal irregular region Sudoku, or as I like to put it, the normal Sudoku rules. Because you don't have to. You just have to say designated 9-cell region, right? Anyways, we also have little killers, where digits along a marked diagonal sum to the number indicated outside the grid. So, for example, these two digits must add up to 10. These digits along this diagonal here must add up to 26. These digits here along this 5-length diagonal add up to 24. And across the entire puzzle, this diagonal must add up to 27. So, for example, if this were, say, a 3, this would have to be a 7, because these two digits along this diagonal must add up to 10 because of the little killer clue given. And finally, we have Dutch whisper lines, or as I like to call them, whisper 4 lines, where digits connected along an orange line differ by at least 4. So if for example, this was a 3 here, this digit would have to be 7, 8, or 9, because those are the only digits which are 4 or more away from 3. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Let's learn how to Sudoku. Sorry. Anyways. So, what are the... So this is a regular region Sudoku. So we're going to be using that a lot, I'm feeling. Each region, again, has the digits 1 through 9 exactly once each. And so does each row and column. So, because of that, we know certain digits have to be the same in certain situations. So in row 2, we have all of the digits are in the same region except for 1. Well, where is that digit going to have to be then in that region? It has to be here. So these two are the same. So we're going to mark them with letters. So we have A and A here, right? Because these digits are the same. So therefore we can remove all of those digits, and these are the digits 1 through 9. These are going to be these are the digits 1 through 9, so these must be the same, so therefore these cells are the same. Same with this one. Actually, I guess we could color these. Let's make this green, I guess. So what about the digits here? Actually, so let's make this light, medium, dark, green, pink, orange, red, yellow, and blue. This digit is the same as that, so this is medium. Where is medium in this region? Can't be here, can't be here, it has to be this cell. Where's the medium gray in this region? Can't be here, can't be here or here because of mediums in the columns, so it has to be here. And it's going to be the same along here. So these are all medium because of the same logic, right? This medium eliminates medium here, and you can't have medium here because of the mediums in the column. So this must be medium, etc., etc. Where is the dark in this region then? Dark can't be here, it can't be this digit, so it must be here. Where is the dark in this region? Can't be here because of dark in the row, can't be here because of dark in the column, so it must be here. Therefore, these must be dark for the same logic, right? This dark eliminates dark here, and these two darks eliminates dark in the column, so it must be there, etc., etc. And we can keep going down this path, right? So in row 4, or actually in this region, where is the green? Can't be here because of green in the row, so it has to be here. And then green can't be here anymore or here, so this is green, and you're going to have green that way. So this all same logic. Pink can't be here, pink is here, and then it has to go, that traverses this way. Orange can't be here, so this is orange, orange, orange. Red can't be here, so this is red, red. Yellow can't be here, so it must be yellow here. That leaves this digit as light, and then we have something similar, right? This digit, we have light and blue left in this region here. This can't be light, so this is blue, this is light. We have, in this region, light, blue, and yellow. This can't be blue or light, so this is yellow. This can't be light, so this is blue, which makes this light. So then it traverses this way. So these are all lights. Blues have to go this way. Yellows have to go this way. Reds are going that way. Oranges go this way. Pinks go this way. Greens go this way. Darks go here, and then this must be medium. Okay, so this blue is nine blues here along this diagonal. So 27 divided by 9 is 3. So this has to be 3. That's 3 in the corners. We celebrate because we know we're close to solving this. Light and yellow add up to 10. That's not too helpful. Actually, that's not too bad, I guess. Light and yellow add up to 10. Green, medium, red, and pink add up to 24 with 3. So green, medium, red, and pink add up to 21. So we have light and yellow add up to... Light and yellow add up to 10. Green, medium, red, and pink add up to 21. So that's total 34 for blue, red, pink, medium, green, light, and yellow. That leaves the remaining digits as orange and dark. So orange and dark add up to 11. Right? Orange and dark isn't along this diagonal. Orange and dark is not along this diagonal. Orange and dark. Okay, so orange and dark add up to 11. Light and yellow add up to 10. So orange and dark, light and yellow. So 10 plus 11 is 21. Therefore, green and pink add up to 5. 26 minus 21 is 5. So that means green and pink are 1 and 4. Okay. So since green and pink add up to 5 is 1 and 4, That's 5 plus 8. So green and pink are 1 and 4. That's 8, right? 24 minus 8 is 16. So that means medium and red have to be 7 and 9 to add up to 16. Okay. So to add up to 10 here, we can't have 1, 9, 3, 7, or 4, 6, because we have 1, 4, and 7, 9 accounted for. So this must be 2 and 8. So light and yellow have to be 2 and 8 to add. Oops. Have to be 2 and 8 to add up to 10. Okay. Well, yellow has to be 4 or more away from 7 or 9. 8 can't be that, so this must be 2. So yellow is 2. Yellow is 2. And light must be 8. Okay. We know orange and dark must add up to 11. And it cannot be 2, 9, cannot be 3, 8, cannot be 4, 7, because the 7 is accounted for. So it has to be 5 and 6. Well, of these, 6 cannot be 4 away from 7 and 9, so this can't be 6. Therefore, orange is 5. So orange is 5, which means dark is 6. That leaves red having to be 9. Because it has to be 4 or more away from 5. So this is 9. That leaves mediums as 7. So pink has to be 1 to be 4 or more away from 5. And greens are 4. And that's it. So fairly straightforward. Obviously, 3 times 9 is 27. 4 plus 7 plus 3 plus 9 and 1. 9 and 1 add up to 10. 3, 7 add up to 10. 4 plus those add up to 24. Obviously, 2 and 8 add up to 10. 4 and 6 add up to 10. 2 and 8 add up to 10. 1 and 5 add up to 6. So that's 26 along this diagonal. Yeah. And then 2 is 7 away from 9, which is 4 away from 5, which is 4 away from 1. And that's how you solve it. Yeah, fairly straightforward. It's very good use of irregular region Sudoku to limit where things are, right? This is one of the interesting aspects of irregular region Sudoku, right? You can create a lot of restrictions based off of the geometry of these regions. So it always has some interesting little implications with irregular region, which you don't have in normal Sudoku. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.